All right.
How it works. Underneath is just...
Okay, it's a Stirling engine, and a little history about Stirling. Stirling was a piston, and this is cast iron. The cylinder is cast iron. Yeah, so there's no lubricant here at all.
Yep, every household needs one.
Yes. And I say, I built all these on my one-arm blade.
Can you build me one? Well, give me a price. I need one. Every household needs one.
If you guys could work out a deal.
Yes.
A paddle for a Stirling engine or something.
Anytime.
I have a friend who's a real machinist. And he's in the business of doing this. In fact, he's building two Stirling engines now.
For really? I mean, for
not the same as this. He might be persuaded to sell this.
no, I mean, what are they for?
So I'm going to see him tomorrow.
Well, I want a teeny tiny one like this, just for demonstration purposes, as you know, as a nice subject for conversation. Boy, this is. I need one.
Very nice.
I graduated, I retired from IBM Research, and I've always liked doing things with my hands. I built model airplanes, and I got into the full size to what I built an active pilot and fishing. But I've always liked building things. Always been fascinated with little engines, things that run. And, so I've got a machine shop in my basement. I got a Bridgeport milling machine, and I got a Monarch lathe, which is, these are, the lathe weighs like 3,000 pounds. The milling machine is close to that, plus all the tools. And I build these little things. People ask me, well, do you have a small lathe? And I say, no, I got a big one. And a model maker at work once told me, if you have a little machine, you can only make little things. If you have a big machine, you can make big things and little things. So, I've got that. And so, as I said, besides these, I've also built a couple of live steam locomotives. Now, the first one's about that big, and I belong to a club up in Southwick, Massachusetts. An outside track, and this little locomotive is coal-fired, and I have a car, you sit side saddle on it, right, and it would pull the three of us. It's really incredible the amount of power it had. And I built a much bigger one. All I have to do is finish the boiler, and I haven't gotten around to it. And I have it running on air. And maybe at a later time, I'll bring the locomotives here. But anyway, let me explain some of what you see here is a Stirling engine, right? Or hot air engine. It's named after Stirling, who was he was a minister, some sort of religious guy back in the early 1800s, and he invented this. It's a complete closed cycle. And what's happening here is the heat from the water here. There's a big piston in here. It's going up and down, moving with that, and it's transferring the heat from here up there, and then it pushes this piston up. The plate cools, and then it sucks it down. So it's a complete closed system.
Where's the plate? In that disc?
There's a disc inside here, right, that's moving up and down. Just a little smaller in diameter, from what you see. And that's a hot air engine.
When the hot air makes the disc go up, expands, the disc goes up.
The disc goes up. This goes up, right, and it pushes that piston up.
So what allows it to come back down there?
And then it cools. And then it gets, you know, this dries it down, and then it sucks that piston
The
down.
air or the diaphragm cools?
The air. The air cools. The diaphragm is an insulator in here that's moving. This will cool, right, and that gets heated. And that's running on this water, and before it ran about an hour, you know. We started it,
That's just hot water from the tea?
just hot water from the pins.
It could be anything that's hot. You
Yeah.
could put a candle in it.
Yeah, you know, it don't run on any kind of heat.
It runs on the temperature difference between the bottom plate and the top plate.
Exactly. And also, if I took ice, fill that with ice, it would run, but it would run in the other direction.
That's how you go reverse, right?
Yeah, that's how you go in reverse. And these, all these other engines here, this is a single cylinder, double acting, you know, steam engine. And just to show you, so it doesn't take an awful lot of pressure. And, now I call that one a slider, and I started with this one here, right? It's exactly the same as that, right? And then I decided to build one a half size. This one here is a half size of that. Then I decided to build one 3/4 of the size, which is that one, and then I built one 1.5 times, which is this. And I'll run them all for you. This one right here is a 4-cylinder radial. All right. This is a little different. It's got what they call a Scotch yoke, a single cylinder. This is a 2-cylinder, a vertical. This is a beam engine. These little ones here are oscillating engines, and I'll run those. And this is a real tiny one here. The bore of that is 1/8 inch. You know, they sound like bees when they're running. And this is a horizontal. This one here is interesting in that there are 2 pistons in one cylinder, and they come together in the middle. When I was in the Navy,
How close do they come? They don't
very
touch.
close. Very close. I don't know. I don't remember. If you want to know, I can look it up. But they don't touch anyway. But the ship I was on a submarine chaser, and they had 2 great big diesel engines, spare bank Morse, they were like that. And they were 10-cylinder with 20 pistons. They had a crankshaft on top, crankshaft on the bottom, and the pistons came together in the middle, sort of like this. And they were started with air pressure. So whenever we wanted to, let's say, back down, you're coming into the pier and you want to stop, you'd have to stop the engine, right, and restart it in reverse. You have to reverse the screws. But they would start, you know, very, very quickly. So anyway, let me run them for you.
Huh?
Go ahead. Let's start with this one here. I control the speed with this valve. Can you see it? I mean, it'll...
Go ahead and get up and see it.
Yeah, it's running.
That's something to do with cooking.
Oh, yeah. Almost couldn't see it.
Yeah, it's running pretty fast.
Yes, it just,
Right? Just running with...
Jeez.
That's running. See it?
yeah. Do it again.
Okay. Yeah, I can run that one.
Well, we can hear it now. We can hear it, yeah.
Okay, and then let me run this one here.
Looks like an oil derrick.
This is like, I don't know how many of you remember, who are old enough to remember the dayliners on the Hudson River.
Yep.
They had the big beam that would run back and forth with the side wheels and the paddle wheel. Well, this is sort of the same kind of an engine.
I think the ferries used to go back and forth had some kind of like
Yeah,
setup like that.
yeah, they were all steam powered.
Is that the old Alexander Hamilton?
Yeah, as a matter of fact. This one here is a 4-cylinder, and that will self-start. If I have enough pressure. Yeah, there it goes, okay.
That's the radial.
It's a radial,
Yeah.
Well, that's something.
That's something. It's like, look at that thing.
Is it turning?
Oh, yeah. Go look at it.
You know,
Yeah,
Quite some power.
yeah.
I like it.
Okay. And this one here, it's just a 2-cylinder vertical.
I got an RC seal.
What happened here? Yeah. It's pretty well balanced.